Alright, welcome to the session 2 of the lecture 12, and in the previous lecture we were talking about that how given some of the knowledge base, how we can extract the information into the forward chaining, means how we can utilize them to get the new informations. Now in this session we will be talking about how we can go ahead into the backward manner, because sometime it may be possible that going backward is easy, because if you go forward taking all the conditions, it may be possible that the things that come out to be maybe very large. Okay, this is the big problem, because when you start from the zero things, you see the complete tree, and therefore at the end, in this example is such that you are getting only a small number of things, but generally it is not the case. Most of the time you may be getting lot of the things, and therefore it will be very difficult for you to go ahead. Alright, so this backward chaining gives you a method by which you can go ahead into the backward into the query. Okay, if the query Q is known to be true, then no work is needed, because if say for example these things are given to you, and these what I want to say that these things are given to, let's assume that alright, let me take that. Let me say that these things are given to you. Okay, these things are given to you. Then and you want to find out whether Q is true is not. Your question is this, and your question is this, that whether Q is true or not. Okay. So this procedure says that you initially test for the Q only, means query thing only, and try to see that is there any information is given that Q is by itself true. If it is given, then no work is needed. Otherwise, you see that where this particular information is included. You see that this Q is included in this particular sentence. So you see that if you go backward from the Q, you see that if P is true, then my work is done. Okay, because if P is given, then you can apply the modus ponens and you can find out the Q. So now you, instead of initially you started that if anyhow you can find out Q is true or not, and if you didn't succeeded, then you went backward and tried to see that whether P is true or not. Okay, this is how you go backward. Alright, so how to find out whether P is true or not? You again see some formula. You see this is the only formula that includes, it tells that whether L and M is true or not. So now the question is whether L and, it gives you whether L and M both should be true. It is AND thing. If the both are true, then I'm only happy. I cannot see this. Then for the L, you see that there are two possibilities, means A and B if they are true. And for C, you see that if A and B are true, then you can say that L is true. And for the M, you see B and L are true. So if L you find out true and B you find out true, then you can say that this is done. So to verify this particular part, that whether L is true, you can see that A and B are true because these things are entailed into your knowledge base that they are true. Then by this you say that okay, L is true. L is true. I find out that L is true. Okay, if L is true and B is also true, it gives you that M is true. Okay, in the backward chaining you find out that M is true, and when these two things are true, they simultaneously give you that P is true. And when you get that the P is true, it immediately gives you that Q is true. So this is how the backward chaining works, and you see that in this thing, this particular sentence was not needed, and similarly you can see that there would be some other applications also where very less number of things you need to explore, and then you can find out your solution. So is it clear? Any questions? Backward chaining is very similar to the forward chaining, but instead you start from the goal thing, and one by one you keep expanding until you find out hit a particular place where there is some truth assignment is given, and then you construct upper thing and try to see the solution. It is clear now? Okay, all right. Now next thing that we want to talk about in this session is the first order logic. And first order logic is actually more formal way, because earlier things were very less expressive, and first order logic is more expressive than the previous things. And here you can entail more knowledge into the system. So this is another way. And first order, second order, and higher order logic we talk about, and we'll be discussing that what these things are. Okay, these things are pretty similar, simple, and very easy. And we are just going to talk about them. And here into the first order logic, we have four things that are: one is the constants, and there is a variable, and there is a predicates and the functions. These things are there. So what these things are? So let me just put it here and let us talk about this and what these things are. So one by one let me discuss. So constants are something, just say for example of constant is if I say that some name, okay, something, if it is a fixed thing, say as a Raju is a constant, okay. Variable, similarly X can be a variable, and whenever you have a variable there is associated domain from where it can take the value. For example, X can take the, if I say can take the data from Raju, Mohan, dot dot dot, I mean these things are possible. So X can take any value, I mean these names could be given to that this. And what is predicate? Predicate is something that is very important, that tells you that whether it's a true, predicate could be true and false. So if I have a predicate says as a male, okay. So if I say Raju inside, so it means that Raju is a male, okay. If I say friend, say predicate if, it may also be possible that Raju is not male, okay. Then what would happen? This predicate would be false. So predicate could be true and false, okay. The friend is given to you. The friend can be what can be friend? Say I say Raju and Mohit. So they are friends, okay. And say like, okay. I say Raju Mohit. If I say this, and then I have to specify that what does it mean. In every case I have to specify. So this is a syntax, semantics. So this is the, actually when we specify that like Raju Mohit, it is only the syntax part, and when I tell that what does it mean, it is a semantic part. The semantic part we have to specify every case. Here it means that Raju likes Mohit, okay. So if I ask this question that whether like Mohit Raju is true or false, can you tell me? If I say that like Raju Mohit, this information is given to you. So can you tell me that like Mohit Raju is also true? No, there is no way, because I cannot say that it's false, but I cannot tell this because there is no such information. So you should be cautious about this, that whenever you are writing like this, you should be cautious about this, that this particular thing may not be true. All right. Then the third thing that is important is a function. And function actually computes something, and function independently does not exist. It actually exists with respect to a predicate, and whenever we have a function, it gives you something to the predicate. For example, say I define a function as age. Okay, age is a function given something, say Mohit. It tells you that what is the age of Mohit. All right. I can say that phone number of Raju. It would give you something, some information, but independently you cannot use this thing. You have to use this thing inside a particular predicate, such as enter function could be that mother, okay. And here one minute, and another function could be a mother. Another function could be a mother. Given the Raju, if it is a function, so it could not be true or false. It would give you something. Given the Raju, it would give me the name of the mother, say Suman. Okay, it gives you Suman. The answer of this mother Raju would be Suman. So Suman is the mother of Raju, kind of thing. But you cannot utilize this information. You can only pass this information into some predicate, such as So such as parent. Parent is a predicate where you are going to supply three things: X, Y, and Z, where X is the person, Raju, Y is the father, and Z is the mother. So here you can write out the formula into this way, such as parent X, father of X, and mother of X, like this. Alright, and inside, if they are true, there would be some condition that would be, it is again a kind of evaluation system that would tell that whether this is true or not. This can be any information that gives you whether it is true or false. Alright, you understood this? Okay, so there are few more things that that you should also note this, that px could be for every x. If I write some predicate of x, that if I don't specify anything, the predicate would be true for every x. Sometimes we say that there exists some x such that this. Okay, so we would be seeing this, that for example, if I want to say that every man is mortal. Okay, every man is mortal. So I can say that for every x, okay, human or an x, okay, when human of x is a predicate, that tells that if x is a human, okay, implies that mortal x means he would get mortal. I have a question, let me just address this. In the regular languages we use functions quite often. No sir, what is the context that we are saying functions should be used inside the predicate only? Okay, all right. Look, in the predicate logic, everything should be, because you are going to provide some information, okay, data, a kind of knowledge that you are going to provide. So those knowledge will be provided in terms of the predicates only. So in your knowledge base, everything would be only a predicate. You understand? But only predicate cannot give you a knowledge. For example, what is the predicate? Human. Human is a predicate. If you provide something, if I want to tell that this is a function, this is a predicate, human. I say who is human? I say that human Ram. Ram is a human. Human Mohit. Mohit is a human, kind of thing. Okay. So if I write these things one by one, it actually specifies that Ram is a human, Mohit is a human, and then I have to also specify mortal, say Raju. So he is mortal, kind of thing. Means so similarly, these things are giving me a handle to provide the truth or false. But if I want to refer, sometime it is also required that sometime I want to refer some of the properties of these things. So those properties are actually come from some computation or some other sources, and I need not to assign a true values because they are only information. Those information are actually not useful until a true or false is assigned to them. So for those things we use functions. Okay, as I told you that if I say that the function is, if the function is father, yeah, function is age. I think age is a better way to write. If I say age and I say Mohan, so what is this? That this would give you a value, say 32. So this is the age of the Mohan. You got the age of the Mohan. So what to do with this? Is it true or false? No. What should be the predicate? That can apply for job. Okay, this is a predicate. Here you supply the name, say Mohan, and age of Mohan. Okay, and in this predicate it would be tested if age of Mohan is greater than say 18 years, and then only he can apply. Kind of this. You understand this? All right. So that is fine. So you understood this part, that there could be sometime you say that for every human is a mortal. Sometime you say that there is someone who is king into the country. So you say that there is someone who is king. How can you write that there is someone who is a king? There is this x such that human human X and king X. X is human and X is king. Okay, so there is someone who is human and who is king. So this means that there exists a king. There exists a king. So you can you put for every X you can write? No, because everybody is not king. Okay, everybody is not king. So like this. So we will be seeing this in more detail. And here, wherever you are going to write these things are actually variables. I told you that these things are variables. Sometimes when you specify the values, then it becomes a constant. Otherwise, you mostly you put the variables, and whenever you specify the variable, there is associated domain, and from where this value is coming. For example, if you put for every X, so it means that who are the people? You say that who are people who are living inside on the earth. So then instead could be kind of infinite set where a name of every person is there. So you have to know that whenever you are talking, there is some associated about a variable. There is associated domain also. Also, I want to tell you this particular important line that you should also note down this particular thing, that sometime we can write like this, see this particular formulation. That is a very simple formulation, that for every X there exists Y, okay, such that P of XY. For example, if I want to say that everybody has a mother, okay, if I want to say that everybody has a mother, so I can say that for every X there exists Y such that I can write the condition. What should be the condition? The condition should be this. I can write like this. There exists Y such that mother XY. Okay, X is the, and here you have to specify the semantics. You have to tell it means that X is Y is mother of X. Then only it returns X true. Otherwise, it tells no. Somebody is asking that sir, please differentiate between predicate and functions. So again, it is a very good question, and you should ask these kind of questions. I encourage you to ask these questions. Predicate is something for which you can assign the truth and false. Predicate can be assigned truth and false. Whereas a function are not given for the true and false, they would provide you some other information. For example, if instead of writing this, I can define a function mother X, and now it is a function. Given the X, it would tell me who is the mother. Is it possible, na? If I give you X, then this particular function is going to find out who is the mother of this X. And now whatever the answer is, this answer is not true and false. Otherwise, okay, you cannot assign anything. So these are the functions that give you a thing, such as if I ask like this, that is mother of X. So given the X, you find out what is the age of his mother. So can you say that the person's age is, okay? I think I have an interesting question to write. That can you say this thing that age of a mother is greater than his child? That can you write this? Age of mother is greater than the person. Can you write this? You can write like this. For every X there exists, okay, there exists Y. We talk about human of X and human of Y, and mother is Y of X, and age of X, age of Y greater. This is how you write. And when you write these things, you have to specify each and every part. You have to specify human human X is equal to X is human. Okay, mother XY means X is mother of Y. Okay, age X is a function, gives you age of X. So you can see that into the R things, this is the human is placed over here. This was a predicate. This was also a predicate. Mother was also a predicate over here in this case, and greater is also predicate, and they are put into using the connectives. But this age has only was as a parameter inside a predicate. This is what I wanted to tell, that whenever you have a function, it can go as a parameter into another predicate. Okay, so you have also have to define the and the predicate greater X and Y. Okay, what is X is greater than Y? Okay, so I think here we have done a mistake. So to correct this mistake, what I can write, I can change this thing over here. I can tell that greater XY means this is what I mean by this. Now I am correct. All right. So you see that in this way you can write any statement. So all right. So next thing that I want to point it out, that when we say that there exists X, for example, when we say that there exists X such that X is human, we are talking about a person. Okay, and here we are not talking about the predicate. Means predicate is there. Sometimes we can talk about there exists a predicate. Okay, that would be true on this particular variable. So if we go by those logics, then it is called the high order logic or second order or higher order logic. So when we talk about the existence of the predicate, but here into the first order logic, we don't go for the predicate. Predicates, we assume that they are defined and they are not constructed. Okay, so all right. So let us see some examples into the predicate logic and try to write these statements. Okay, one by one. So let me write the first statement, that not every customer have purchased milk and bread. Okay, so let us use this. Let us write this particular statement. That is the not every customer have purchased milk and bread. How can you write this? So since there is a not, so you can ignore this part. Okay. Initially you write that every customer has purchased milk and bread. Okay. Let me see that. Do I have a question? The question is, can you describe the higher order logic with an example? So we would come back to later. Okay, let's complete this thing. Okay, this part complete. The other, because higher order logic we would talk about later also. So not every customer has purchased milk and bread. So how can we write this into the first order logic? So we would be seeing two things, that how we can write the things into the first order logic, and then because this is going to be a knowledge, then how you can extract the knowledge using this, and how you can do the inferences on this. So both the things we are going to see in this class. So not every customer has purchased milk and bread. So what I need to find out, that somebody is customer. So I have to define this thing, that what is the customer. CUST, customer of X means what? X is a customer. I purchased milk and bread. So he is a shop. Say I say he had shop X Y. If I write like this, shop X Y is equal to. So I say that X has purchased Y. Are you able to understand this? So if I want to write like this, that every customer has milk and bread, so I can write like this, that for every X that he is customer of X, then what does it mean? That it means that shop X and this thing means he had purchased milk and shop X bread. So this is what I say, that if somebody is a customer, everyone who is a customer, he has shopped milk and bread. This is what I write. But I have to write not every customer has purchased this thing. So I can write like, I can put a bracket over here. I can say that not. Okay. All right. So here X is a variable that actually says that if X is a customer, it implies that the he has shopped the milk and bread. And now you can see that now the X, what is the limit, what is the range of the X? X could be anything. You can put cow, you can anything you can put. But if you put cow over here, he is not a customer, therefore it's not going to affect into your system. Only the people who are actually customers, for them you are telling that they have shopped for the bread and milk. This is how you go ahead with this. Is it clear? Okay. Another way to write could be this also, that you see that there exists a customer, because every customer had not purchased the milk and bread. So there would be some customer who has means you say that every customer had not every customer had purchased milk and bread. You say that there exists customer who is customer of C, means somebody customer, and either he have not shopped milk, and here I think that since it's just a reverse order, you understand, na? C and milk and C and C and milk, you can see that it's a semantic difference only. So shop milk C or not shop bread C. Okay, either he have not shopped for the milk, or he had not shopped for the bread, or it may also be possible he have not, because or is true when it is true. Either one should be true, and to make either one of the things to make the true means he have to either not purchase milk, or he have not to purchase the bread, or he had not to purchase both of the things. All right. So this is another way to write the same thing into first order predicate logic. Is it clear? Okay. Now next thing is only one customer has purchased guitar. How can you write this? Only one customer has purchased guitar. Okay. So one customer has purchased guitar. How can you write like this? So this, somebody has written no. Meera, what is the problem? What is the question? You didn't understand the first part? Yes? Should I explain once more? Alright, say this. Not every customer has purchased the milk and bread. So if somebody who is there, means if there exists C and C is a customer, so just see that it and means what the and means, that whenever he is a customer, then only it can be true, otherwise it cannot be true, because into the and everything need to be true. So this statement would be only true when C is a customer. So we are only talking about the customer. So we are talking about the customer. What we are talking, that not every customer has purchased milk and bread. If every customer has purchased milk and bread, so we can write that he has shopped for the milk and he has shopped for the bread, and but this is not the case. So another way could be to write the same thing is this. Okay. Okay. You can write like this, that I think it would be better that you can understand that it is the same thing. However, that there exists customer C, says such that customer is C is a customer, and what is not there, I am putting there, not shop for milk customer has, and shop for bread and C. Can you see this thing? This is easy. If I put like this, is it easy? shop milk C and salt milk this thing. It means that the same customer C is here also, C is here also. So same person has purchased shop for the milk, same person has a shop for the bread. It means this thing. Can you understand this part only? That he has shop for the milk and bread, and this part I am telling not. Okay, so means he has not shop for the milk and bread. He has not shop for the both milk and bread. Alright, he has not shop for the both, because this and says that he have purchased both things, and now I have put not. It means that he have not done this thing. Okay, and this is the same thing as above, because you know that this negation can go inside, and therefore you know that minus of A and B is equal to minus A or minus B. Okay, you know this thing. Okay, so the same thing is there. Okay, similarly same thing is over there. So that's all it is. Okay, very good. You got it, and I'm done. Very happy to see this. So next thing is only one customer has purchased guitar. How can you write this thing? Only one customer has purchased guitar. Okay. So only one customer has guitar, means at least you have to tell that there exists a customer who had purchased the guitar. Means there exists X such that what is there? There exists a customer such that X is a customer X, and shop for the guitar. So let me write guitar X. This means he has shop for the guitar. Alright, it is clear. And there is a condition that and is this, and what is next condition? That nobody else has purchased the guitar, because only one person has purchased the guitar. So then say, and for every y such that X is equal to Y is not true, means if X is not equal to Y, okay, means anybody who is different than the X, what has happened? And Y is a customer, because I will not talk about anybody who is not a customer. Okay, if these two things are there, it means that he have not shopped for the guitar. Y is not there. Shop for the guitar is not there. He has not done the shopping for the guitar. Can you understand this? Is it easy? Yes? Alright. Very happy to listen this. That I think it's very simple, but you have to only understand one thing, that somebody at there exists X who is the customer and who has the shop for the guitar, but at the same time there is another condition that that for every Y who is not X, means except for this person and who is a customer, he have not shopped for the guitar. Blue part once more please. Okay, blue part once more please. I am telling this thing. What is this thing? If I don't write this thing, what is going to happen? If I don't write, remove this part. Okay, let's assume that I remove this part. If I remove this part, okay, let me take this different period. If I remove this part, what is going to happen? For every Y, okay, who is customer of Y, I say that he have not shopped for guitar. Y has not shopped for the guitar. You understand this? Every Y has not shopped for the guitar. This is how I can write. But here I also have to put one more condition, because this Y should not be equal to this X. Okay, because he is not the person, he have purchased this. Therefore, this is extra condition, that if X is not equal to Y, then only I am going to talk about this. Otherwise nobody has shot for the guitar. Alright, so that's very simple, and okay, this is the thing. Now next statement is even more interesting. And what is this? Only one customer had purchased guitar and pen. Only one customer has purchased guitar. You know, If I ask that only one person have purchased guitar and pen, how can you modify this thing? Question is only one person, only one customer has purchased guitar and pen. Okay. So I am telling actually here that it may be possible the person has purchased, other people may have purchased guitar, other person may have purchased pen, but guitar and pen has not been purchased more than once. This is what it is. Okay, the difference is into the first and second one is this, that this second person Y can purchase the guitar and can purchase the pen, but at the simultaneously he have not purchased the guitar and pen. How can you write like this? Okay. Hmm? I think you can go and see this particular part. I think this thing can help you to write this thing. Okay. Hmm. So this thing comes into the picture, means not short for the milk and thing. So I think you could, this condition should be changed. The single condition which was there should be changed by this, so that you say that whenever inside thing if x is not equal to y, because for the x you say that x has short for this, so you can include one more thing over here. You can say put one more thing that he had shop for pen. Okay. And x. Okay. And I think this should be clear to you, huh? Customer X shop and one more thing is there. Okay, one more thing you put over there. And for every Y who are actually not equal to this and who are the customer, they only have to do this thing, satisfy this thing. Both things they should not buy. So this thing you can put over here. How can you put? You can put not and this part would be, you can, how can you modify this to put over here? Not of shop what? Shop guitar Y or not shop pen Y. Okay, this you should put over here. Instead of this, you should put this line, upper line. So can you write this? Okay, should I explain this? Somebody is telling that in the ever problem where the logic for stopping the pen in the first part and the second pen in the second part, that would not work, because then again further you are somehow restricting the first person also, that it may be possibility that first person can also purchase only one thing and go out. That should not happen. For the first person you should tell that he have purchased both the things. So therefore you should write this purchase, that he have purchased the guitar and pen at the same place. Okay. And you should go ahead writing other things at a later point of time. So I would leave you this particular question, and I think the third part I was that how that the highest purchase in the afternoon is more than forenoon. So with this question, that how to go ahead with this, let me tell you that in this part you may be needing to use a function also. So try to solve this particular thing, and I think there should be for your homework. And in case you don't solve this, please shoot a mail before Friday, so that I can include the further solution for this into the next class. Okay. Otherwise, I assume that you can solve this, and we need not to discuss. So we have discussed about the first order logic, that how to here it is more expressive, and therefore it can explain more things. And now we are going to see that how we can find out the inference into the first order logic. So to do the inference, there are three techniques that you can introduce at some later point of time whenever it is required, such as universal elimination. Sometimes if somebody is writing for every x, it feels x king, means every x that he feels x as a king, could be, you can write that Raju feels Raju king, Raju feels like a king. And you represent this as a fact that x is a Raju, and where Raju is nowhere in your domain. If Raju is not inside your considerable domain, then you can change his name and you can say that feels Raju king, because ultimately there would be some person, and if he is not in your database, however at the later point of time you want to find out that, but you can write this thing that instead of you can substitute. And as I told you that using some ground ground things only. Sir, you can explain previous derivation once again. What the derivation? Nitin, can you, in the previous slide, you were writing the expression only. Are you talking about that? You want to how to write that thing? Nitin, you want to ask that? Okay. Third point. Here the third point, only one customer has purchased the guitar. Nitin, let me just tell you one thing, that you please go ahead with the slides because everything has been recorded. We have less time. You go ahead with the recording. If you don't find that my things were satisfied, then you can just shoot a mail to me. Next class I would be addressing this point first. Okay. Because things are recorded. We have more things to cover. Okay. It would not be otherwise. We would not be able to cover some things. So you please see that part because that is recorded. And this thing, I think, this thing let's discuss because otherwise it would be not be possible to cover this part. Okay. This is an important slide that I want to tell you, that whenever you write that for every fields X king, it should be fields Raju king. You can change the name provided this name is not there in your knowledge base. Okay. Extensive elimination be similar here. It is also similar kind. If I say that there exists someone who feels like king, so you can also put a man somewhere. You can write a name over there. Okay. And because there exists X means what? You want to find out someone. So let's assume that his name is man. So you can put his name at a later point of time. You can find out his name. So this is our overall objective is at the end you will be finding out there is someone. If the extensional introduction, sometime if you similarly it is a reverse of this thing, that if you say that there is Raju king and at the point you reach the conclusion, then you can remove this part because you know that he is not into my database. You can say that there exists field X king. If you started with the dummy and you reach to the dummy, then you can put that there exists field king. So to give this thing a proper understanding, I have an example, and we would like to see this particular example. And in light of this example, we would try to see that how we can go further. Okay, this is what the question is. So we want to find out how we can go for the inference, and let us see that how inference can be applied over there. So let us one by one construct the knowledge. So this is what the knowledge base is given to me. It is crime for the Magad. It is crime for the Magad to sell formula to a hostile country. Okay, let's assume that this is there. It is crime for a Magad to sell a formula to a hostile country. So what do I mean that for every? I want to say that for every XYZ. X, Y, Z, such that Magad is a place. So I say that Magad X means X lives into the X is a Magad person, and he cannot sell a formula. And let I say that formula Y is a formula. All right, and I say the third part, X crime for Magad to sell a formula to a hostile country. So I need the third thing also, that there is a hostile country. I say the hostile Z is a hostile country. Okay, and what happens? There is something is being sold. The problem is that this selling. That there is a person who is from the Magad, and there is some formula. There is some formula that is Y, and there is some hostile country that is Z. So what is the problem? Problem is that if somebody sells, what is the problem? That if X sell Y to Z, then what is happened? That there is a criminal. It is a crime. So I say that criminal. Who is criminal? Can you tell me who is criminal? Who is criminal? Can you tell me? Yes, all right. I got the right answer because X is the Magad person who has the formula, and he has given the things to the hostile country. Therefore, who is the criminal? X is the criminal. So this is what the first thing that I know. Okay, all right. And the second thing, second information that we have, is the country Bhind, an enemy of the Magad. Bhind is a enemy of Magad. So I say that is a hostile. Bhind is a hostile country because is a okay. He have purchased some formula from Dara. Okay, so there is some formula. Okay, so third information is there exists some Y, that is a formula, and we say that formula is Y. There is a formula, and it is owned by, because country Bhind enemy have purchased some formula, so it is with the Bhind. Okay, and Y Bhind own Y. This is the means there is some formula that the Bhind owns. Number one, that he has some formula. Bhind has some formula. And next part, that this formula कहाँ से आया? From where this formula came? Fourth information, that I say that for every Y that is there, means if it is formula, if some is a formula and it is owned, I think just right, I have to write own, and it is just owned by when Y, it implies that there is a selling involved, and selling of who has sold him? Dara. Mother has purchased some formula from the Dara. So Dara has given Y to Bhind. This is the fourth information that I have. All right. What is the next information? That fifth. Anything else coming from this? Country Bhind. Bhind is a country, the enemy of Magad, means what? That he is a hostile. He have purchased some formula. There is a formula that is owned by this. And since he have purchased from Dara, therefore for every formula that is owned by the Bhind, it is purchased by the Bhind. And then the next thing gives me the data that Dara is Magad. So we say that Magad, and we say Dara. This is all the information I have. Now I want to apply some. Control set. Now I want to apply some logic. Okay. Now let us see that what logic we can apply. Okay. What logic I can apply? Okay. Using these three formulas, what logic I can apply? So let me just take it and let it make some smaller. I think it's not काफी है. Take it a big. Okay. Let's try to see what logic I can apply. So to apply the logic means to find out some inference, I'm going to do in this way. That there exists some formula. I'm going to take the third one. There exists formula. There exists Y. That is a formula Y, and owned by this. Okay. So as we have seen that this existential formulation can be removed by saying that, let me just name that formula. I can say there is P is some formula and it is owned by Bhind P. Okay, this is what we can take it. Alright. and then we have this particular second thing. Okay, this is the second thing. Then I'm going to see the next thing, that is for every formula owned by Bhind implies sale by the Dara to Bhind. So if here existential thing can also be given a new name. If I substitute this by P, what I get? Okay, I can substitute here the P, then what I get from this formula, if I substitute it by say P, then I say that formula P and owned by Bhind Y implies that cell Dara Y Bhind. Alright, here this Y is P. Okay, I told you that this Y is P. I told you that I can substitute this thing with any name because new P is a new name. So this, when I substitute, I see that this part formula P owned by Bhind P, and here I see that formula owned by Bhind P becomes same. Okay, it means that these two are going to produce something. What they produce? This part. Okay, they produce that cell Dara P2 Bhind. Alright, this information I have. And what other information I have? I have another information. This is the one information that I have. And other information is I have this information Magad Dara. Okay, just my target is the first one. My target is the first one because it is going to give me something. So it needs Magad. So Magad, for Magad, this information I have. Formula of Y. So for the formula of Y, I know that formula is P. P is a formula. We have substituted for this. We know that formula is P. Hostile Z, I say that hostile, this information is given to me. Hostile is Bhind. And this information is cell this thing. Okay. So if I can, all these things are given to me, I can say that that this and this and this and this, and where these are the three formulas. What are the X, Y, Z? X, Y, and Z. Can we find out the value of X, Y, Z? X is. Can you tell me the X? X is Dara. If these three things comes out to be, so can you find out X is Dara, and Y is, what is Y? Is the formula P. Okay, and what is Z? Z is Bhind. Alright, and all other things, everything actually goes perfectly fine with respect to the first formula. So if everything goes perfectly fine, then it gives us this particular conclusion. Okay, if everything goes fine, then it gives me this particular conclusion, and the conclusion is criminal X. And what is X? X is Dara. So we see that criminal Dara. So this is how we proved that given these information, we can prove that we can apply our logic, and we can find out an inference, and we can say that is Dara is criminal. We can say yes, Dara is criminal. All right. So this is what was an important step. And 1 minute. The last thing that I wanted to discuss to you, that is a very important thing, and I would not go much into detail. The reason is that lot of tutorials are available. Okay, so there is a programming language that is called the logic programming language, and the name is Prolog. Okay, and you may have seen that I was installing them, and you can write some code into some file, say a.pl, and then you write a.pl dot then to compile this. Here there is also like any other languages, there is a syntax. So syntax is this: if can be written like this, and can be using comma, or can be written using a semicolon, and not is there. And for example, if you write the hello, and new line, then it would print the hello on the screen. So all these things are pretty simple. Okay, so this is a website that is swi.prolog.org. You can go on this and install on your own machine. And I'm just going to give you a particular small examples. Okay, so just see this particular program that tells that. So see that how I'm going to explain. Okay, this is the code. This is actual code of the log that tells the warm blood penguin. So what is a warm blood? Nobody, you need not to explain anything. You just write the warm blood and penguin. It means that penguin, by the system would understand by itself that penguin is a warm blooded thing. Okay, something that there is some property that is warm blood, and penguin has this particular property. Okay, all right. Right, so you be with me, just try to understand that what I am going to tell, that this is a syntax that warm blood penguin, means penguin has the warm blood. Next I told that the warm blood human, the system would understand that human also have the warm blood. Produce milk penguin, penguin can produce the milk. Produce milk human, human can also produce the milk. Have feather penguin, penguin has a feather. Have hair human, this particular property is true for the human. And now my question is, this particular thing is a function. This particular thing, I think function goes till this thing. Okay. When there is a full stop, it means that it ends. When there is a comma, it means that and. Okay, these things are ended one by one. So mammal X is a mammal. And now since there is a this thing, if now I am writing if condition, that X is mammal if these things are satisfied. What is satisfied? That warm blood X, if X has the warm blood, X produces milk and X have hair. Okay, I think X have hair. Okay, so if I define like this, if this is my program, so you can understand by yourself that this is the program, and there is a underlying logic that understand this. And now I can ask if I put this and I compile this into the Prolog thing, and then I can ask this question, that mammal penguin, whether penguin is a mammal. So by system would by itself go inside and put that mammal over here and try to see that warm blooded penguin should be there. Yes, it is there. Produce milk penguin should be there. It is there. Have hair penguin should there. Since have hair penguin is not there, it means that it says no. Can you understand this? Very easy. Okay, so you can understand the logic. And another thing that is very interesting for the Prolog is this, that you should not ask this kind of question. You should ask the query, means mammal X. If I write mammal X means mammal X. X is a mammal. So system would automatically try to find out that who are the suitable candidates for this X using this particular data. So you can see that he is going to tell you that X is human, means by itself in this database it had done some churning and came out with the answer that X is human. That is fantastic. Okay, because if the system by itself tells you that he is a human, then what else is needed? Similarly, this is one very important property. I tell you that please go ahead and read this particular magnificent language, and that is not very difficult to read and get an understanding of that. Another thing, see, there is a similar kind of is even. If I want to find out that whether the number is even or not, I can write a function like this, is even. This is the function, is even X. If I into this file, another file, if I define is even X, and how I define like this, X is X by 2. This is the formula. X percentage 2 means if you divide, X is divided by 2. Y is X divided by 2. Is actually equal. Instead of equal, it uses is. Okay. So this is the same thing. Y is equal to X divided by 2, but it is integer division. Double means integer division. Then the decimal goes away. Then you want to compare. If you multiply this with the 2 and see that whether it is same or not, this is the equal, means equality check. If you find out that these things are red, this is a fine, then it would tell that it is even or not. You can see the formulation. I have a question. Let me just check. Warm blood is defined instructions by Prolog. No. Warm blood is not defined instruction from the thing. I am defining this property, and then it is assigned to which thing? Warm blood penguin. I am telling that this is what the property I wanted to tell, and then it is associated with the penguin. And here also I have written something that how to use that. So this is even. You see this? This is how we can write it. And similarly, this is nothing more than just printing a writing a printing a fancy printing a statement. That here is also you can write something, just write what is your name, then read X, you can read something and write hi and then write the name, and full stop is something ints, and in between if there are some commas, these are the commas, there are no full stop. It means that these all the things one by one need to be done. So many more things are possible. So I just want to encourage you that you go on the YouTube, just search for the a video and see some video. This is the link from where you can download. Let me tell you one thing, that I'm planning to have a uh, assignment on this. So your assignment would more probably be on the prologue, that you have to by self-paced have to learn and have to solve some problem. And you can see that it's pretty easy, means giving something and then asking from the system that what is the answer. That is very easy, and I think that is not very difficult to go ahead. All right, so that's all for today, and thank you for being with me. And you can see these two references, chapter 7 and 8 for the Russell and Norum, and this Huth and Rayan book, chapter 2, and those things would be covering something. And I am also telling you that please go ahead and read some of the things from the internet. Okay, that would be very nice. Hope you understood this lecture and you like this lecture. Thank you very much for being with me. I am equally very happy for this. Thank you.